Okay, welcome everyone, or welcome back if you've joined us earlier in this series. We're here to talk about advancing sustainability with AI. We're virtually at the Hurry Institute for Computing here at Boston University. We have a wide array of centers and initiatives focused on everything from cloud computing to privacy to AI, of course. Here's a quick look at the program. So I'll do just a short intro here, and then I'm going to hand it over to today's host, Garrett Johnson. He's going to take you through the panel discussion, and then there'll be a Q&A as part of that as well. Just to remind you, if you've been with us, or if not, to give you a sense, we've had 3 speakers so far in this series. Claire Montaglione has talked about deep unsupervised learning for climate informatics. We then had Aisha Walcott-Bryant join us talking about AI's potential for healthcare to mobility in Africa. And finally, Francesco Fusonarini talked to us about the role of artificial intelligence in achieving sustainable development goals. We've gathered back now in the form of a panel, which is the culminating event for our series. AI and sustainability, we've already heard from the speakers, have tremendous potential, but also concerns and worries. And I think today is hoping to delve into that. Let me talk about our host for a moment and introduce him to you. Garrett Johnson is a assistant professor of marketing in our Questrom School of Business here and a junior faculty fellow at the Hurry Institute. Garrett researches digital marketing, particularly measuring its effectiveness and examining its privacy issues. He has a PhD from Northwestern University and previously taught at Simon School of Business and Kellogg School of Management. So Garrett, it's all yours.
Thank you, Eric. It's my great pleasure to introduce our featured panelists today. So first off, we have Claire Montaglione, who is an assistant professor and the associate chair for inclusive excellence in the Department of Computer Science at the University of Colorado Boulder, and the founding editor-in-chief of Environmental Data Science. She completed her PhD and master's in computer science at MIT and a postdoc at UC San Diego. She holds a bachelor's in earth and planetary science from Harvard, and her research on machine learning for the study of climate change helped launch the interdisciplinary field of climate informatics. Our second panelist, which we hope to join us later, is Aisha Walcott, who's located in Nairobi, Kenya. So may be having some technical challenges, but she is, I'll just briefly say that she's a senior technical staff member and research manager at IBM Research Africa. She spoke on Monday about some really interesting research applying AI to all sorts of interesting social healthcare problems like malaria. And then our third panelist, or second panelist, depending on your perspective, is Francesco Fusonarini, who works as an associate professor at the KTH Division of Energy Systems and is the director of the KTH Climate Action Center. His focus is on addressing multidisciplinary sustainability development related issues, that's a mouthful, including how future climate change and action energy choices in AI will affect the achievement of the climate and sustainability development goals, which he spoke really interestingly about on Wednesday. So Francesco holds a PhD and docent degree in energy and environmental systems analysis from KTH, and 3 Masters of Science degrees in environmental and sustainable energy engineering from several places: Politecnico di Milano in Italy, UBC in Spain, and KTH in Sweden. So we have many degrees and many smart people lined up for you today. So before we get started, I want to remind folks to follow the Hurry Institute's social channels for the latest updates on upcoming events. Our event today is going to be recorded, and you'll be able to find this on Hurry Institute's YouTube channel. So thank you all for attending and joining us today. So please join me in welcoming Claire and Francesco. I'll clap. Eric's clapping too. That works. So welcome. I want to get started with a question that's forward-looking. So what are some of the primary expected benefits of AI and smart sustainability efforts that you see in the future? How do the benefits that you've seen delivered to date inform your optimism about this? And what accompanying concerns do you worry could mitigate these benefits? How about we start with Claire?
Cool. Well, while I'll collect my thoughts, I want to thank you for the introduction, but also say that I'm an associate professor, and given all us academics know how hard it is to get tenure, just thought it was worth making that clarification.
Did I say assistant?
Associate.
Oh, I apologize if I messed that up.
Oh, no worries. So we're already seeing actually many of government agencies across the world use AI in some weather prediction applications, whether it's tornado forecasting in Oklahoma, or Hadley in the UK is using AI with DeepMind for precipitation nowcasting. IMD in India is using AI to help forecast aspects of monsoon, which we know affects the GDP of the Indian subcontinent, but is notoriously hard to forecast what kind of extremes we're going to see there in terms of flood, drought, etc. The Korean Meteorological Department or KMA is also using AI, and also in Japan. So I think there's mostly a reason for optimism. I see a lot of other potential, so I'm not too worried. Maybe Francesco will come in with some worries, but I at this point have a lot of optimism.
Great, Francesco.
Thank you. Well, first of all, just building up on what Claire said, I think the advances in understanding extreme weather events and climate adaptation are very promising and can really make a difference. And I think we discussed that a bit, and maybe expanding that field in the climate challenge. When we think about the sustainable energy transition, there are some very good progresses made there. And I think in my seminar, we spoke about some of those, such as enabling smart cities, enabling matching electrical renewable production with demand, and so on. There are so many applications also in the fields of energy efficiency and smart demand response that that can enable this very difficult challenge of achieving net zero carbon societies, which, as you know, depending on where you are in the world, it's a target that has been set by governments, mostly to 2050, for instance, in the EU and in the US, and in some other places like China 2060, and now recently with the latest COP in India by 2070. So advanced technology is really needed to achieve that, and there are many good applications being developed. But yeah, of course, then in the seminar I gave presenting this cross-disciplinary study that we did, looking at the potential positive and negative impacts of AI across the 169 targets of the SDGs. Of course, there are some important, let's say, areas of concern. And among the many that we found that can be addressed, but with the I guess the ones that I'm most worried about is the issues of equality of access to technology to benefit from AI, and I would say also AI ethics, and I would say also if we talk about energy systems and so on, cybersecurity.
Great. Well, it's good to start on an optimistic note about the future too, and here's some things to look forward to. So before I ask my second question, I just wanted to remind those who are watching us today that if you have any questions, I encourage you to post those in the Q&A, and we'll keep an eye out for those. So the second question I had So one challenge with AI is that certain applications of AI, like self-driving cars, require just so much data that only the largest companies can hope to succeed. But on the other hand, data scientists can now benefit from some of these off-the-shelf AI models developed, for instance, for language and image processing. So can you speak about this tension between this kind of winner-take-all versus democratization forces of AI? And are there any particularly inspiring examples that come to mind when you think of applications of AI to say sustainability that's been made possible by this democratization of these AI tools? So how about we alternate and start with Francesco for this one?
Yeah, and I guess this question relates to my first worry about equality of access to this technology. And it's not only within companies, or among companies, it's among countries. So some countries and some companies that have the access to this technology, the access to these data centers and so on, can broadly benefit from advancements in AI, while other countries, less rich countries or less technological countries, can benefit much less. And that's a fact that most AI applications have been developed to date for wealthy, technology advanced countries, which again presents many issues. And I think, of course, with advancements in technologies, you see more applications also to low-income countries. There are some good examples, I think, also in actually in climate adaptation, but probably Claire can speak more about that. But yeah, this is a very, very important issue to be addressed, so that again, this technological divide doesn't become again an income and benefit divide.
Great, go ahead, Claire.
Yeah, thank you so much for bringing up climate justice. That's really important to us here at CU. We're actually, I think, the only engineering school, at least in the US, that has a funded center around resilient infrastructure with sustainability and equity. So bringing social equity and climate justice right into a school of engineering. But actually, you mentioned the Colorado School of Mines, and in terms of engineering education, they have this humanitarian engineering thrust that brings social justice right into engineering education. And I think they're actually some of the leaders. We're trying to work on that as well. The other concern I have, in some sense, I think the way you phrase this question, it could be looked at as a positive that there's all these off-the-shelf AI models. But the risk is that if people are using off-the-shelf AI models to then form conclusions that advise stakeholders without the proper understanding of the trade-offs inherent in the technology and how these algorithms work, you can get spurious predictions or bad estimates of risk that affect stakeholders. But this actually gets into the twin problem of the career paths for people that now are starting to be trained at the intersection of AI and some of the domains that help address climate change and sustainability. And so if we can create career paths for students trained at this intersection to get them into the energy domain and each domain that will be working on sustainability and climate change solutions, then we can better ensure hopefully both inclusivity, but also that each individual domain has access to the expertise that will help them use models in the ways that they were designed to be used and have more trustworthy results.
Thanks, Claire. I appreciate you bringing up the career paths. Certainly, like when I saw the three of you speak, I thought it was very inspirational that people could be doing this kind of work and having this kind of social impact. I saw Francesco raise his hand. I think he wanted to build on what you're saying.
Yeah, no, of course. And I think So there are some very good examples at different universities, but also in governmental agencies of very important AI applications for societal benefit and also education that benefits to that. But more broadly, again, in this large review, we saw that most AI applications follow commercial interests, which it's not bad, of course. Many commercial interests also have co-benefits with societal interests, but there are many societally important questions not being addressed just because there is not enough economical reward. So that's another issue that is still quite open, and of course, depending where you are in the world, governments and universities are trying to fill the gap. But still, as the, let's say, commercial or let's say the big tech companies have much more strength in doing this, some of these developments. Again, the two are not going, let's say, at the same speed.
Francesco, thank you for making that point. I think the equity issue is one of the most important issues in this space, and so I'm glad that we draw some attention to that. We did get one question from the audience, and since it's kind of career-oriented and connected to Claire's research, I'm going to direct it to her. So Rohit asks, how important is the knowledge of GIS for an experienced data scientist who wants to switch to working for climate tech?
You know, that's one form of data, but I don't think you should get caught up on knowing any one format of data. If you know data science, then you know a lot about methods, and you know your collaborators can help you get access to different types of data in the format that you need it. You know, satellite remote sensing data there's copious amounts of that. There's also data that we view as data that is the output of climate models, and there's copious amounts of that simulate different scenarios into the future. So I would maybe not get, I mean, I'm glad that you're thinking of switching to work in climate tech, and I would encourage that. And I think if there's any particular data technologies or formats that you need to learn, you can learn them on the job. So yeah, I would encourage you to switch.
Awesome. Yeah, the grass is green over here. I guess Francesco's hands down. Okay, so let's
maybe.
No, go ahead, Francesco.
Sorry, no, on the question, just sharing, and for the audience knowledge, my background is from energy systems and yeah, I would say climate mitigation adaptation, but not climate sciences. So I think it's very interesting that we also have there that is more on climate and AI. But on the energy side, just saying that our group has been working a lot with GIS data, and there are some, especially when we were discussing these advancements for societal benefits, there are some very important application with GIS data being done to fight poverty. So there are some new algorithms that can track poverty from geospatial data. And also we've been involved a lot in using models to compare solutions for electricity and cooking energy access in collaboration with, for instance, the World Bank and the Clean Cooking Alliance. And of course, GIS has been very, very useful to enable some applications of national energy planning and so on. So I would say it's quite a rich field. Then, of course, there are many other rich and interesting fields, but I find it a very fascinating and developing field.
Great, thank you. So I wanted to move on to another question about kind of putting this into practice and advice for leaders and data scientists. So I think we all agree that advancing sustainability is one of the most important things for us to do as a society, and AI is a powerful tool for that. And I think it requires, an all hands on decks and mentality and the ability to replicate success quickly. So what advice do you have for leaders and for data scientists for successfully advancing sustainability using AI? So for this question, I'll start with Claire.
Interesting. I think I'll start with the data scientists. Basically don't work in a vacuum. So if you're at BU, you're in Boston, there's so many different labs in BU and at all the other universities on whether it be in the energy domain or climate science itself, air quality, or other aspects, the water cycle, et cetera. Find a collaborator. And so depending on your stage, like if you are a student, ideally you could find another student who's in a different field. And it's these personal collaborations that are really going to make sure that the work that you're doing is impactful. So yeah, just don't sort of sit in a void or connect to some online communities if you're not in Boston or a place with tons of domain scientists, as we call them. So for leaders, I've come up in academia, and so leaders within a university, some are doing a better job than others, but they need to start valuing interdisciplinary work. This is also an issue, for example, at our funding agencies and at many of our journals, right? The reason why we founded the Environmental Data Science Journal is that apparently in the domain, if you're submitting a science paper, but you used really interesting machine learning, that had to get relegated to this little methods section that apparently people don't even really pay attention to. And if you're doing a methods paper and apply to a machine learning journal, then you can't just double down on one application area. You have to show that your method works on a variety of different application areas. And if you're really committed to fighting climate change, maybe that's not, the direction that you want to take it. So I guess leaders in evaluation of work and funding proposals at granting organizations and in academia need to take a broader view that we're going to need these sort of all hands on deck and transdisciplinary and convergent approaches to tackling sustainability and climate change. And then for higher level leaders, policymakers that are actually making funding decisions, realizing that AI research, if harnessed to combat climate change and advanced sustainability, are basically probably the cheapest key we currently have to unlock insights from the data that we already have. We just have so much data from remote sensing and also climate modeling and a variety of other types, but generally it hasn't been methodically analyzed using some of these cutting edge AI tools. And so, more funding and priority needs to go to that if we want to be able to be very nimble and quickly address the clean energy transition and, society adapting to these increasing extreme events and cascading hazards.
Thanks, Claire. Francesco, go ahead.
Yeah, well, first of all, completely agree on the need to work multi or transdisciplinarily across disciplines to address these interlocked sustainability challenges. That's, of course, a top priority. And I would say maybe for AI leaders that want to work on sustainability, I would say a first step is to get into it, and not only for passion, which makes a lot of sense by itself, but also for the opportunities, because when addressing sustainability challenges and the net zero emission goals will need to mobilize trillions of dollars of investments. There will be lots and lots of jobs and opportunities, quite in an exciting way as well. So it's not only about being passionate about it, which many of us are, but of course it's also a lot of opportunities. And from the university, from the university and educational side, I guess as universities, we have kind of yeah, an obligation to try to both teach to our students sustainability. And there are many good examples across many universities, just speaking about KTH here in Sweden. Now, in all courses, in all programs, all educational programs, there must be education related to sustainability. And also, universities should be quite adaptable to new technologies. And I would say also in our universities, but again, I know this example, but many universities, there have been new programs on programming, on AI, and so on. So I guess if I take it from the point of view of universities, we really have an important duty here to educate future leaders with the right skills. So be very adaptable, even if it means scrapping some of the old textbooks and really doing new things for our students.
Great. Certainly at BU, we think that this is really important, right? We have the Hariri Institute. We're building this gorgeous multi-story data science building. So we're really embracing this as a key part of the future. So we had a question from Emily. The question was, with the growing use of AI, what should be the balance between data-driven modeling and analysis and more physics-based analysis? So Francesco, would you want to take a stab at that?
I might actually bounce the question back to Claire, because, and just for everyone's knowledge, so I've been, I would consider myself more an expert on sustainability and energy systems. I've been doing some modeling, but I wouldn't consider myself an AI or machine learning expert myself. So I'm probably not the best person to answer this question.
Yeah, thanks for the question. There's been a huge effort in basically a hybrid space between data-driven methods and physics-driven models. I'll refer you, there's a website called the Kavli Institute for Theoretical Physics. Don't get scared by the theoretical. They hosted a 6 or 7 week long program in the fall 2021 on machine learning for climate science. And all the talks are streaming online, which is why I refer you there. You can get free access to the talks. There's some interesting talks. So machine learning is coming right inside climate models to model things that either we don't know the physics for, and actually there's still a lot of these. For example, in the ice, in the cryosphere and glaciers, and these very important issues about when large shelves of ice are going to break off into the ocean, which has huge effects on sea level rise and affects different regions differently in terms of sea level rise, which then can lead to coastal flooding, et cetera. So sometimes the machine learning can come in to emulate physics that we don't understand yet. Sometimes it can come in for purely computational reasons. Cloud modelers do understand how to model cloud formation, but it requires looking at a quite tiny spatial scale, really predicting whether a droplet of water will condense on an aerosol particle. And it depends on also the properties of the aerosol particle. With aerosol particles generated from combustion, human-driven combustion, different than some of the natural forms that we might have from volcanoes, et cetera. So to model that at scale can't be done computationally now in the framework of an entire global climate model. So machine learning can be used there. So that's one aspect of machine learning coming in and helping modeling. On the flip side, there's this whole goal around physics guided or physics driven or physics informed machine learning, where, I mean, the nice thing about physics is that we have a certain amount of predictability because there are conservation laws, conservation of mass and energy laws that we know have to be met, and there's a certain amount of inertia that gives some predictability, at least on shorter terms. So if you're taking a completely data-driven approach and you add to it some physical constraint, that can sort of guide your search for solutions. So there's an entire literature on that as well. And then there's sort of in between things like data assimilation. So most data observation products that you have been snapped to some grid, making some assumptions, because when they're out being measured, they're not necessarily measured on an exact grid. You know, think of floats in the ocean or balloons in the atmosphere, or measurements made on a ship in the ocean. We don't perfectly get a geospatial grid, and we have to create a data product that's gridded. So some data products are made just using statistical assumptions to grid them, but some are smoothed in using those physical laws, such as the conservation laws, et cetera. And that is a process called data assimilation. And so I, actually have been sort of doing some soul searching, is that when we take observations and then feed them through physical models to impose those assumptions that allow us to get a physically, believable or realizable gridded data product, then I personally don't want to go and use a physics constrained machine learning because it's already gone through the physics, and I just want to do a completely data-driven method. But you raised just a really good point, and there's sort of rich scope for interaction between physical modelers and data-driven modelers from AI.
Thanks, Claire. I think you're the perfect person to answer that question. So that was a great answer. All right, so we got another question now from Catherine, who's asking about ethics in AI and how that's growing in importance. And so her question is, how do you view the ethics around AI, and to what extent should or shouldn't there be more conscious effort to acknowledge, if not address, these ethical concerns? And how about we start with Francesco for this?
Yes, of course. Well, taking the second part, there should absolutely should be work on ethical AI, and many organizations and also many governments are moving on that. So, for instance, the EU have released some, I think it's called guidelines for trustworthy AI, and there are many good examples from several countries. And also international organizations. So that is the top priority. One thing that of course is being discussed is that ethics, and in many cases ethics regulations, are also related then to the country or to the region where you are in, and that of course creates problems in which you can have some countries with very stringent ethical regulations and other countries with no ethical regulations, and of course that doesn't have a simple solution. But of course this is important, and it also relates to the transparency of these models, on how they're used. So there are many facets on it, and again of top importance.
Go ahead, Claire.
Yeah, I'm glad you asked this question. And within sort of mainstream AI, meaning AI that's not only focused on sustainability, there is a huge effort on ethics. I would encourage you to look at workshops and conferences with keywords such as FATE, which stands for Fairness, Accountability, Transparency, and Ethics. And there's a lot also around the bias that can arise in any classifier or AI model that is trained on historical data, because we know there's historical bias in the most data sources that we have. It's really interesting, though, to see that this actually does directly bear on sustainability as well. I don't have the citation, but I recently was shown a plot of where in the US we have radar coverage and we don't have it everywhere. It's an expensive measurement product. But it's when it's overlaid on where the preponderance of African-American communities are in the US, there's hardly any radar coverage over them. So in terms of protecting population, if we don't even have data for certain populations as to whether they're going to have extreme weather risk, how can we be creating fair models and predictors? So bringing ethics right directly into sustainability and the study of climate change is crucial. Also, what is the threat of climate change? What is that threat? It does not existentially threaten humanity to survive, because there will be a few rich people in bunkers in New Zealand who will survive anything and come out, and then they can, have children, etc. It directly threatens equity. There are going to be some people that have good air quality and some people that don't. So climate change and sustainability is directly an existential threat to societal equity. And so looking at ethics in the framework of sustainability is extremely important. There's macro issues that Francesco has been alluding to, such as countries that are less developed actually don't even contribute that much to climate change, but if they're located in hotter regions, they're going to experience drought and water quality issues first, and already are. But also some of the issues that I raised in our own country. And in our own country, we've had a legacy of environmental injustice. So if a community is low resourced or low income, or communities of color, often we're targeted to put incinerators and other large polluters in their neighborhoods, then they already have worse public health outcomes, for example, when it comes to respiratory disease. And so any climate solutions need to not only try to be just going forward, but ideally work to actually undo that legacy where certain communities have been made more vulnerable due to a legacy of climate injustice. So this ethics does have to be studied in the context of social justice, directly in the context of for any advancements on sustainability and climate change.
Thank you both. Now I wanted to turn to a question from Rohit, who asks about startups in this space. So what are some promising startups that are creating offerings either in the climate intelligence, carbon accounting, agriculture, energy, or other kind of neighboring things in the commercial setting? So Claire, can I start with you, or should I start with Francesco?
Sure. I don't know what you mean about shed some light. You want to just have us list names of startups? I mean, there's
what would,
a huge...
what would be a couple startups that you're excited about, and what do they do?
Yeah, I guess a lot of startups contact me, and I don't really want to endorse any particular startup, but there's a huge amount in precision agriculture to help with agricultural insurance. There's a big space around risk, where the target people to be bought by would be like reinsurance companies. And then there's a lot in the energy domain. Yeah, I guess there's many startups, and I'm not at this point ready to endorse any particular startup.
Francesco?
Yes. So, similar answer. I'll not name specific startups, but there are really a lot. And I guess in an exciting space, at least for me to look at, is looking at startups that enable some parts of the energy transition. There are good startups on demand response, smart homes and smart appliances, Something that also is quite interesting, there are some good startups that are looking into helping individuals understanding their carbon emissions. So maybe looking at some things or having some data on the movements or on the things that an individual buys. They can analyze and do a decent estimation of how their carbon emissions are, and also try to give some suggestions on how to influence that. But again, it's a very large space, so there are really a lot, and many of those startups are not startups anymore. They're actually very flourishing businesses.
Thank you. And this is actually kind of connected to what you're saying about some of these particular startups that are working in the energy transition space. So what are some of the key specific challenges that AI technologies can assist in the energy transition? So this is a question from Bryant, and I think I'll start with Francesco for this one.
Yeah, I guess many aspects. I would say that the one that is very interesting that I started mentioning is really when in the electrical system, when integrating a lot of variable renewables, there are some issues. So, for instance, if you have a lot of wind power, that varies when the wind is blowing, or a lot of solar, which also is a variable renewable. You need to match that to demand. One way, well, is to store this extra electricity that you produce, but then of course that has costs. But there are some interesting applications again that help matching demand in a household or in the city to when the power is produced. And this can be optimized at the level of seconds or minutes or even during the days. So I think that's quite an exciting development that could help also avoiding spending some of the investments that will be needed on storage of otherwise unused power.
Yeah, we're also working. So here in Colorado, there's the National Renewable Energy Lab, where they do a lot on solar and wind. And to Francesco's point that there's so many moving parts when you if you're a grid operator and you wanna incorporate renewables, right now, you have to assume a lot of uncertainty around when they're gonna be operational and outputting power. So we've shown that machine learning can actually help improve the forecasts. And so this is important both at like minutes to minutes level forecasts for reducing short-term uncertainty, but also long-term, like sub-seasonal forecasts of the output of solar or wind can help reduce the sort of variance, basically robustify the forecasts to give grid managers more confidence on their energy planning. And that's something that we think is very important. And then depending what brand of AI you do, there's a lot around autonomous systems. So drones are being flown around individual wind turbines to observe them, to eventually lead to better predictability of turbine failure or wind outputs really in real time. And so all the tools from operating autonomous systems all the way to processing video data or any time sequence data that we have sensing those wind turbines will come to bear. So I think there's a lot of scope.
Great. So I have a question from Ashish that I'll direct at Claire. So Ashish's question is, The association of AI with informational surplus as opposed to traditional problems of information asymmetry underlying many sustainability goals. To what extent is unsupervised learning in the climate change context? Do adaptation efforts predicate themselves on informational surplus?
Okay, so I'll stay away from the economics jargon that I don't know how to use and focus on unsupervised learning in this domain. I actually spoke about that here at the Institute series talk that I did last week, which should hopefully be available online. But yes, I mean, we argue that you're going to need to double down on unsupervised learning. We did an example with avalanche where the ground truth data was actually the sensors were humans trekking into these dangerous alpine regions to check for avalanche deposits. But if we can learn a virtual sensor, so a mapping from a satellite remote sensing product to what the human would have observed, right, we can deal with the fact that it's very dangerous and hard to collect more data. This is also the case for radar. So I mentioned the huge gaps in radar coverage in the US. And the US is one of the countries with some of the most radar. It's generally expensive, and so not the whole globe is being sensed. But if you could again learn mappings from other forms of ubiquitous sensing to what the proxy values for radar would be in locations where we do not have measurements, this would be a huge breakthrough. It's something that NOAA itself in the US is interested in. So yes, to the extent if you're figuring out what to focus on in your studies of AI, definitely have a look at unsupervised learning techniques. And there's a lot of exciting techniques coming out right now around various unsupervised deep learning approaches.
Thank you. Yeah, I really hope that there are some students in the audience in addition to researchers, because I think this is very inspiring to see what you can do with these tools. So I wanted to go back to this topic of emerging markets. I really wish that Aisha was here because she's located in Kenya and have a great perspective on it. But what does the future hold in emerging markets with different resources and cultures? So one thing that comes to mind for me is that emerging markets have been able to leapfrog certain technologies. So I think of like phones, less of a desire to create at least a broad-based hardwired phone network by skipping straight to cell phones. But we see this similar leapfrogging arise with AI adoption. And let's start with Francesco for this.
Well, I would say to an extent, yes. There are some, I would say, very different applications. And then, of course, it really depends what we mean for emerging markets. Do we mean are we thinking at least developed countries, or kind of half of the way countries? But I think there are many interesting applications that are being developed. And I think one that I mentioned before is which I'm quite passionate about, is how new technologies are being used to address poverty. So just as an example, up to a few years ago, to understand the levels of poverty in an area of the country, even local policymakers or local government had to travel there to understand and target policy. And one example is energy and water access. But now, thanks to some of these algorithms, you can really, target some of these efforts, especially at the national level, thanks to geospatial data is one of them, but also machine learning and certain new applications that are being developed. And then, of course, you mentioned the penetration of smartphone, which is really high. For instance, Sub-Saharan Africa, which enables a whole new lot of applications. And one example is, for instance, the high penetration now of pico-solar power in many African countries that have been to an extent enabled thanks to some of these new IT and IT application and programs, for instance, that let some give new possibilities to access to credit and of payment. So again, just to conclude, very different challenges, but yeah, very exciting ones as well.
Thanks, Claire.
So I'll speak, I don't study economics, but I'll just speak to some really exciting advances in bringing AI to developing markets. There has been a project called the Deep Learning Indaba, bringing top deep learning researchers to interact in a conference type environment in Africa, and that's rotated around different cities and been held annually. And this was sort of the brainchild of someone at DeepMind, which is part of Google, and so received funding from them. And then from that, some Latin American AI researchers said, we want to do the same in Latin America, and launched KIPU, which is spelled KHIPU. I went to the kickoff event of that in Uruguay, and it was just really amazing to connect with students from across Latin America and local businesses that were using AI. So I'm not saying that's necessarily going to cause a leapfrogging, but there are efforts from more resourced AI groups to go to the developing world and bring AI education. And I'm really excited to support those efforts. There's been a bit of a curveball with COVID. But yeah, KIPU kicked off in late 2019. And so I do hope that continues as well. And the deep learning Indaba, check it out. I think that has been running continuously for several years.
Great, and I'll say one advantage of this COVID world we've become accustomed to is that we're able to have this sort of event with people on two different continents, and be able to do it with a zero carbon impact or near zero carbon impact, which is kind of refreshing. Okay, so I'm going to try to get two more questions in. So the second to last question is from Scott. How does the quantity or quality of data that is currently being used for your models fall short of what you would like it to be? How should we encourage the production of more and better data? Claire, do you want to start with this? You mentioned a related point earlier.
Also a slide in my Hariri presentation was about kind of the unique challenges in this domain that in the past, so before this massive measurement era, we do have some hints to past climates, some proxy records, biological ones from tree rings and coral growth rates in the ocean, or sediments where we know that different species thrived better under different temperature and atmospheric concentrations and nutrient availabilities. But those are very few and far between. So the ones that look way back into time, like cores from glaciers, are very spatially sparse across the globe. So there we have sort of a collection of small data problems. Now we have massive amounts of very high or fine resolution geospatial data of all different kinds, also going up in the atmosphere and down in the ocean. And we're in this deluge of data, but it's only been, different measurements have only come online in the past couple hundred years. So it doesn't give us a long record. And that's why we actually turn to climate models. So when the IPCC, the Intergovernmental Panel, puts out their reports on climate change and is able to conclude that that it was the human combustion of fossil fuels that really forced this increase in CO2 and in temperature, what they're doing is running models and showing that you couldn't achieve the temperatures that we have observed without sort of simulating that forcing, that increase in greenhouse gases. So we turn to models to get simulated data that gives us the only lens we have into the distant past and the distant future. And then we're back into like a big data setting, because these models evolve millions of parameters over time across the globe for atmosphere, ocean, land, and cryosphere. And so you ask about where do we need more data, and different companies are coming online with hyperspectral imaging and individual smaller measurement devices that'll give us more and more spatial granularity. And yeah, I don't think we actually need more data. We just need to analyze them in intelligent ways. And sometimes that means using spatial diversity to gain insights where we don't have temporal diversity or a long time frame. But I'm getting a note that we're wrapping up. But thank you for the question.
Thank you for the great answer. I'll give Francesco the last word here before wrapping up.
Yeah, maybe just building up on the data issue. I guess it really depends on the field. And again, in our group, we've been using a lot of models, also including some type of AI to address poverty. And over there, working in low-income countries, data availability is really an issue. So in that case, yes, we need, and of course, yeah, you can use some machine learning and so on to use at best the data that you have. But when data is quite is not much, it's still an issue. And then maybe just to close, I mean, first of all, thanking the organizers and the Hariri Institute for this excellent series. And I would say it's quite exciting how well these two fields of AI and sustainability, which I would say well, a few years ago were not that interconnected. They're merging and getting closer and closer, and I think that will open a lot of very interesting opportunities.
Thanks, Francesco. All right, so thank you all as panelists for a great session and your great individual sessions over the past week. I want to thank Catherine D'Angelo for all of her great efforts in the background to make this distinguished series happen. The video again is going to be posted on YouTube, so I encourage you to check it out. And we want to thank the Hariri Institute, my fellow junior faculty fellows, the series organizers, and especially our co-sponsor for this series, the BU Institute for Sustainable Energy, for your help in putting this together. So thanks for joining us, and I hope you have a great day, and also hope to see you at upcoming events.
Thank you.
Thank you. Bye-bye.